Vertical asymptotes. The line x equals to a is a vertical asymptote of the graph of a function f if f of x increases or decreases without bound as x approaches a. So I want us to talk about vertical asymptotes. I'm going to use a graph that we have dealt with previously so that we can discuss vertical asymptotes. We just learned how to graph logarithmic functions. We would change from logarithmic to exponential and then plot our points by choosing our y's to get our x's. So what I'm going to do is I'm going to use these two graphs to determine our vertical asymptote. Well, when I look at this graph is going on and on and on in the right direction, okay? In other words, for your domain, it goes on and on and on to positive infinity. The domain, where does it stop? On the left side of the x-axis. Well, this graph gets closer and closer and closer to the y-axis, but it never touches the y-axis. So notice I'm drawing a vertical line. This is my vertical asymptote for both graphs, actually. This is the original f of x equals to log base 2 of x. This is f of x equals to log base 2 of x minus 3. This one is a vertical shift down 3 of the original. You see I moved every point down 3. But both of these graphs are getting closer and closer and closer to the y-axis, but it never touches. Now the question is, what is the equation that represents a vertical line? A vertical line is named with x equal to a number, just an x. So the name of this vertical line, which is the y-axis, is x equals to 0. Okay? So in your online homework, you will have to determine the vertical line that these graphs are getting closer and closer and closer to, but they never touch. So both of these never touch the y-axis, and the name of the y-axis is x equals to 0. Now, I want to take this first graph, this one right here, and I want us to determine the domain and the range of the original graph. Well, the range, what y's are being used? When you think about it, this graph goes on and on and on. So every negative y is being used. This graph goes on and on and on this way. So every positive y is being used. So as far as the range, it's negative infinity to positive infinity. And it would be the same on the lower graph, which is the vertical shift downward graph. The range is also from negative infinity to positive infinity. Every negative y has been used and every positive y has been used also because it's going on and on and on. Now, as far as the domain, what is the domain? Well, in looking at the domain, what x's have been used? You see none of the negative x's have been used. We've not used -1, -2, -3. We've not used those. Actually, we've not even used 0 because these graphs are getting closer and closer and closer to 0, but they never touch. We've used +1, 2, 3, 4. So actually, the domain of both of these graphs would be the same. The domain being used would be from 0 to positive infinity, but not including 0. So your domain is everything greater than 0. So the domain would be the same for this one, from 0 to positive infinity. The range is negative infinity to positive infinity. But as far as your domain, the domain that has been used for both of these graphs would be from 0 to positive infinity. The range for both of these would be from negative infinity all the way up to positive infinity, because this graph is just getting larger and larger and larger. Therefore, all of your y's in the positive would be used as well.